Hello, we're on page 392. This is Module 3, Topic 1, Lesson 2, and we're going to be focusing on Activity 2, 3, and Talk the Talk, and there will be assignment at the end. So what we're working on in this video is looking at graphs and either writing a story problem or looking at a story problem and writing a graph. Now with this, for the most part, what we have are continuous graphs where the graph is all connected versus discrete graphs. Discrete graphs are not connected. They're like a series of points or unjoined lines. Okay, anyways, so let's look at the situation here. It says the graph shown represents Greg's distance from home after driving for X hours. So we got to just keep in mind our units here. So the x-axis is time in hours. So we can see that Greg drives from 0 to, looks like 10 hours. And the distance, he's driving from 0 to 200 miles from his home. So he'll be driving away, he'll be driving closer, and we're just going to answer these questions dependent on this part of the graph. Okay. So with this, number one, it says analyze the graph between 0 to 2 hours. What was Greg's distance from home after driving for 2 hours? So we're looking from here to here. And if you go, right, from here, go up to the graph, you can find out, right, how far Greg went. So I'm going to erase this, but Greg was 120 miles, right, from his home after driving for 2 hours. Okay. How fast did Greg drive during this time? Now, for U.S. system, we measured time or speed in miles per hour. So this was 120 miles per 2 hours. So what we'll have to do is divide 120 by 2. 120 divided by 2 is 60. So he traveled 60 mph for miles per hour. Okay. And we're going to keep referring to this graph. C. How do you know that Greg traveled at the same rate for the first 2 hours? So, how do we know that he didn't go 80 miles an hour and then 40 miles an hour? He's still going to get to 120. How do we know that it was constant the entire time? So by looking at the graph from 0 to 2, which is just this part, right? That part is a straight line. So since it's a straight line, that tells us that he went 60 miles per 1 hour. We could even see that here, right? That right here, right? 60 miles in 1 hour, or 120 miles in 2 hours. Okay. Now with this, let's say Greg could have easily went like this and then like this. He was driving a certain speed and then went faster. But since it's a straight line, that's what tells us it was constant. We're going to say because the graph is a straight line. At least that part of the graph is a straight line. Okay, we're going to be flipping back and forth, but let's go and move on to page 392. So 392, number 2, analyze the graph between 2 and 2.5 hours, and we're answering some stuff from there. So 2 and 2.5 hours. So this right here is 2, 2.5 is right here. So we're going to be judging it from this part essentially to this part. Now, although I draw these lines, what I'm really focusing on is this horizontal line. Okay, well, we're saying at 2 hours, Greg is 120 miles away, and 2.5 hours, he's also 120 miles away. So, think about that. If you're 120 miles away at this time and 120 miles away from your home at this time, has anything really changed? Not really. So, what can we say for that? How far did Greg travel from home between 2.5 hours to 2 hours to 2.5 hours? Greg did not travel. We'll say any miles from home. Right, he didn't get further, he didn't get closer. Okay, so B, how fast did he travel during this time? He traveled 0 miles in half an hour, so that we would just say this in miles per hour, so 0 miles per hour. So maybe Greg, he traveled 120 miles, maybe he went to go get gas, go get food, something, but he was staying put for about 30 minutes. And describe the shape of the graph between 2 and 2.5 hours. So what told us this? What told us this is because the graph was a horizontal line. Right, when we have a positive slope, that means you're increasing. Negative slope means you're decreasing. Horizontal line means you're not increasing nor decreasing. So that, right, nothing's changing there. All right, and then the parts that we're going to have to annotate here. So number 3, label each segment of the graph with letters A through G, beginning from the left, and record in the table the time interval for each segment. Then describe the distance Greg traveled in what direction at what rate. So it already did 2 of these for us. A is from 0 to 2, and the expectation, what we're going to write here, you're going to describe. Provide a little bit of a description. So Greg traveled 120 miles from home at a rate of 60 miles per hour. And then the one that we just did, B, 2 to 2.5 hours. Greg traveled or took a half-hour break when he was 120 miles from home. Okay, so let's go ahead and label the varying parts. So this part here was A. This part here was B. And then the other parts that we're going to have, this increasing line is C. Horizontal part is D. Negative slope is E. And then we have F. And then G for this last part. Okay, that was good. So we already did A and B, so we'll describe C. So for C, we will have to put our interval. Okay. I'm going to put this in because we're going to have quite a few lines here. Looks like C starts here and ends here. So we'll put this in red. This is from 2.5 hours to 4.5. And then we can also look at how far they're away. All right. I'll come back to this, but this is 2.5 to 4.5. So from 2.5 hours to 4.5 hours. What's happening there, right? How much further did he drive and at what rate? So as you can see, we're going from 120 to 180. So that's a change of, he drove 60 more miles, right? 180 minus 120 is 60. But that took him, so let's go and write that. So you traveled 60 more miles. Put MI. Right, from home and at a rate of, if this is 60 miles and from 2.5 to 4.5, that's 2 miles. Or sorry, 2 hours. So that was 60 miles in 2 hours. So how much is that in terms of miles per hour? We're going to have to divide 60 by 2. 60 divided by 2 is 30. So he traveled 60 more miles at a a speed of, or we said that this is 30, or 60 divided by 2 is 30 miles per hour. All right, 30 miles per hour is not that fast. That's like driving down Washington. Well, the non-school zone for Washington. All right, and then let's go to D. All right, from D, we already have the left part of it. It is 4.5. And then, maybe I should put this in a different color. Put blue. So from 4.5 to 5.5, it's horizontal. So Greg is 180 miles away from his house, and we're not moving at all, right? Because at 4.5 is 180, 5.5 it's also 180. So he took maybe another break, or maybe he went to where he needed to go. But let's go and write that here. So this is from 4.5 to 5.5. or maybe it's a long road trip. Greg took a 1 hour break when he was 180 miles from home. Okay, we're going to complete one more part of this, and that's going to be E. I'd welcome you to figure out F and G as a you do, but let's go ahead and figure out E. All right, from E, so we're starting right here. We know that Greg is 180 miles from home at 5.5 hours in his journey, but let's also go to this next part. I'll put it in purple. Right here, Greg that's 8 hours, and he's 120 miles away. So looks like it's decreasing. So this was 180 miles, and now after 8 hours, we're 120 miles. So he's getting 60 miles closer to home. So he's going back home. Okay, right. That's why it's telling us it's decreasing. The distance from his home is not as large. So this is from 5.5 to 8 hours. All right, let's write that in. 5.5 to 8. Okay. So for E, looks like that's 60. All right, Greg traveled 60 miles. And instead of from home, he's going towards his home. And we'll say towards home. And that was 60 miles in, it looks like 2.5 hours. Right, 2.5. So we can try to divide that. All right. So we're dividing it to just determine what it is per, or how much it is miles per hour. So I'm going to just put this into my calculator. 60 divided by 2.5. Looks like he is going, so this equals, we'll say at a rate of 24 miles per hour. All right. So you can pause the video at this point, try to figure out what the answer is for F and G, and then let me know if you'd like for me to check. I'll get rid of this other stuff. Okay, so F, this horizontal part, and G, this negative slope part. All right, and then from there, we're going to continue, but in a slightly different context. It's just a little bit more practice. We'll do this a little bit faster compared to the previous part. All right. So for this one, it says that the crew at a community swimming pool prepared the pool for opening day. The graph shows the depth of the water in the swimming pool after X hours. Okay. Why do you think the crew emptied the pool and then refilled it? So like, why would a pool need to be emptied anyways? Probably for cleaning. Oops. So we'll say cleaning, repairs. Yeah, just wanted to clean the water. We'll say cleaning and repairs. All right, and then this next part, we're also annotating the graph. So the pool water starts here. We'll say that this is A, goes down for B, down a lot more for C. This part is D, and this part is E. Okay, so let's do this in parts. So for A, what's happening here? So that's where we got to find the 2 points on the side of the line segment, like this and this. Put this in a different color. So this is from 0 hours to 2 hours. So 0 to 2. The water, since it's at 7, it's 7 here and it's 7 here. Well, it's not getting more, it's not getting less. So water stayed at a 7 foot or 7 feet 7 feet deep. Okay, so 7 feet deep, that's pretty much taller than everyone. For B, so let's get rid of this part. For B, that's from here to here. So that is from 2 to 6. And then if we look at how high we are and how high we are here, it looks like we started at 7 and now we're at 5. So the water decreased. Water decreased. I'll write it out, but I'll probably abbreviate later. 2 feet, right, from 7 to 5. And that is from 2 to 6. So that is from, right, 2 to 6, that's 4 hours. So we're going to say per 4 hours. HRS. Okay. All right, let me go ahead and erase this part. All right. Now moving on to the edge of C. So C is all the way down here. It's right here. So for C, that is from 6 to 8. And then from 6 to 8, right, we started at 5 and now we're at 0. So we decreased 5 feet. So we're going to say that the water, I'll just put DEC, decreased 5 feet per, we'll say 2 hours. Right, from 6 to 8 hours. All right. Continuing this. For D, right, we already have the first part, but the second part of this, the other point in the line segment is right here. This is at 14 hours, from 8 to 14 hours. Okay, you can see that it's horizontal. They're both at a height of 0. So the water just stayed empty. It was empty for 6 hours. Okay, and then the last part that we have, we're going from here, which is at 0, to all the way here, which is at, it looks like that's 20. What's the height of that? That is at 9 feet. Okay. So from 14 to 20, the pool filled, right, we said it was a depth of 9 feet. From 12 to 20, that is 6 hours. Oops. All right. For this, C, did the crew empty the pool at the same rate the entire time? No, right? So otherwise it would be a straight line. It would go from here to here, which it didn't, right? It decreased for B and decreased for C, so we're going to say no. It's not a straight line. And then D, why does it make sense that the graph of this situation is continuous rather than discrete, right? Those are the two key vocabulary terms, right? Continuous means that it's all connected. So it makes sense because for any given amount of time, so we'll say for any time, comma, there is a certain amount of water. Okay. I mean, like, let me draw a graph that's like similar to this. Let me draw it off over here. Something that's similar to this, let's say I don't draw the lines, but I draw the points. So this point, it goes down here, all the way down here, here, and then back up. This is a discrete graph. And with a discrete graph, you can see that there's breaks here. Right, we could tell that, like, what is this? This is 2 hours. But the thing is, in between, there's gaps. And when you have gaps here, that's saying that the water just kind of like disappeared, right? That wouldn't be true, right? So an example of like a discrete graph is like problems on a test, right? You can have 1, 2, 3, 4 problems, but you can't have like problems that are in between. Like you can't have 2.5 problems, 3.5 problems. and so on. So this is, I should circle it, this is continuous. Okay, and then for activity 3, before we get to talk the talk, you're matching. So we're going to do some of these and I'll have the rest be you-dos. Let's say we're going to do 3 of these. So it says students at this high school designed ceramic drinking cups for an art project. They pour water into each at a constant rate, so pouring at the same rate. With here we have 6 cups, and then we have 6 graphs, and we're going to write the name of the person and match them to the graph below on number 1. So if you look at the graph for this first one here, this one says pretty much there's no like arc or line like the other ones. It's hard to see, but it's actually just on the x-axis. What this is saying is that like 0 seconds, we're at zero ounces of water, or sorry, the height of this. Maybe it's in terms of inches. And at the end, there's no water in this cup at all. Which one of these, if we poured water into it, would hold no water? That's going to be Ryan here. The reason is because Ryan made a gap in the cup, so it's just going to pour right out. So for this, let's put Ryan. And you know what, let me cross up his name so I know we've used it. For this one, B. So this one tells us that it's increasing, the height is increasing. This right here, let's say from here to here, that is steeper than this part here, which I would say is like flatter. So what this says is like, yes, when it's steeper, that means this thing fills up faster. And then when it's flatter, it fills up, but not as fast. So what is something that would fill up faster toward the beginning and wouldn't fill up as fast at the end? That would be Jacqueline's here. I don't know. I'm just going to put Jackie. The reason is because if we fill up water here, and we're pouring at a constant rate, like this part would fill up pretty fast because it's narrow. But as you get to like this upper part here, right, this would fill up, but not as fast because it's wider, and that's going to be something that takes more time to fill up. Like, I don't know, you may notice if you have like a skinny cup like this versus a wider pot or bowl, right, that's going to fill up at different rates. So this one, that is Jackie. Let me cross it off. And we're going to do one more. I'll have you do the rest as you do. This one, we're saying for graph C, fills up super fast, right? It's steeper even compared to this one over here. And then it like almost exactly like just plateaus near horizontal. So this is very steep. And then we have something I'd probably say more wide. So what here would say very, very steep / skinny, and then wide at the end. So that is going to be Blake's. This is going to fill up really fast, and this is going to take some more time to fill up. So Blake. All right. We have 3 more remaining, and for graph D, E, and F, I'll have you try to figure out which one of those you believe is correct. All right, and then when you're done, let's move on to the next page, page 396. We're going to do one of these. Let's say the first one. We'll have the first one be the one that we do together, and second as a you do. So this one is popcorn at the movies. You and a friend go to the movies, decide to share a large bucket of popcorn, write a story. So what's happening with this situation here? All right, we've been having right, we matched right a graph to a description or an image. Now we're taking the image and writing a description. So what can we say about what's happened with this popcorn? So you think about this. Is this increasing? Is more popcorn going into the bucket? Is less popcorn going into the bucket? And then at what rate? Does it stay at the same constant rate? Are we eating at the same rate? So on. Okay. So for this, we're going to say that we buy the popcorn, and at the beginning, right, so it's kind of horizontal, but then it decreases, and it decreases really fast toward the end. So we'll say that it's flat. We'll say that this is going down, and then this is going fast, right? Fast. I don't know. I'll say fast down. Okay. So probably we're just like at the beginning. We'll say at the beginning. We're just kind of sampling. We're just like tasting it a little bit, nibbling. I'll just say tasting a bit. Then I will say we sit down. Maybe we go to our seats. We sit down and we'll eat very quickly. Or maybe we're sharing it with someone else, right? We're sharing it with someone else, and they're kind of like helping us, right, eat the popcorn. Otherwise, you're just eating popcorn by yourself, and that's kind of sad. Okay, anyways, we'll leave it at that. You go to determine what's happening with this second situation, and let's go and look at our problems. So these cutouts, this was for a previous activity, so we're going to ignore all this. We're going to go to page 401, and 401, we're doing all of I wrote over here. All of number 1, and there's only one part for number 2. So all of number 1 with all its varying parts, analyzing this graph, and it extends to the back side for A through G. And then number 2, and that's pretty much it. Numbers 1 through 2. Okay. All right, anyways, let me know if you have any questions.